storage room. What's this all about?
Well, this is where we come to play cricket after hours.
Oh, I heard the cricket
Yes.
as I walked in. But it was more the insect type.
Well, yes. We're pretty excited to have the new warehouse. It's very difficult in Australia to be a just-in-time manufacturer, so that we can meet customers' needs and have finished product, and so that we can have materials ready for production, we need a big warehouse.
Show me the warehouse.
Come this way. We were very fortunate in
Look at this.
the racking was already here.
Wow.
So we had to do some repairs and some modifications, but that saved us a lot of money and it made it easy for us to move in. But as you can see, it's giving us plenty of room for storing finished product and plenty of room for storing components.
So what do we got here on these shelves?
Well, on the left-hand side here is eco cell packs ready to go out. As you can see, it's a double depth storage. So we use a reach truck, which increases the amount of product we can store, as well as the next row along. On the other side is we have pre-built cabinets for installing batteries in, ready to go out the door.
So you're not a just-in-time manufacturer?
No,
we
tried
You're the
that.
just in case there's a pandemic manufacturer.
Well, the timing was actually quite good. We did have a few issues right at the beginning with a change in the customs rules in China, but that was a blip for about 6 weeks. But we've managed to get through the pandemic by holding stock.
Wow, that's cool.
Yeah.
Well, I mean, there's A, B, C, D. Does it go all the way to Z?
Almost. I think we're to T or something like that at the moment.
T. Oh, you got room for expansion because you have to stop at Z, you know.
Well, no, then you go A1 or AB or... But yes, lots of room for improvement.
So, more batteries.
Yes, so we bring the cell packs in from China and we then install them into our own metalwork made here in Australia with the cables, which we source from Oztech here in Victoria. Our packaging, our labelling's all sourced from suppliers here in Victoria.
So you're a great Australian story. It's not just that the batteries are made here, but all these components that you're talking about, like the cabinets,
Yes.
the cases,
Yes.
the packaging.
Yes.
What else?
Well, for example, in our cabinets, the copper buzz bars
Yep.
are made here in Victoria.
Yep.
The polycarbonate insulators are made here in Victoria. The metalwork to support it all is all made here in Victoria. So while there is a cost to using local manufacturers, but the benefits are that we're dealing, if we need to make design changes, if there's a quality issue, we're just dealing with a company around the corner rather than dealing with volume from something that's come from overseas. Even sort of little things like we had our printer come to us and say if it wasn't for the work that we gave them during the COVID lockdowns, their family business would have closed down.
Wow.
So it was sort of that circular economy worked for us and for other businesses during the lockdowns.
I guess your staff are made in Victoria too.
Well, yes, we had. It was kind of interesting early in the piece when a lot of companies were laying people off.
Yep.
We had our staff coming to us and saying, "Thank you. You know, we've still got a job." So, look, even before the government provided assistance, we provided time off paid because we didn't want to lose our staff. So while we were having those hiccups with the customs supply chains out of China, we kept our staff on because we had good staff, we'd trained them, and it allowed us to get right back into manufacturing, you know, back in the early 2020s, when sort of things all came back together again.
So here we are walking down, what, H, M? I'm really looking forward to T, because there's going to be something around the corner here that might be a bit interesting.
Well, yes. Part of the advantage of having more space is that as we are building larger cabinets, again, sourced from local manufacturers, we've got space to put it.
Right. Wow, check them out. That's a lot of cabinets.
We have pre-wired cable assemblies, the circuit breaker assembly, the insulators, all ready so that an installer in the field can, or in their own workshop, can fit their inverter of choice, any other switchgear or MPPTs that they require.
Right, so these actually aren't necessarily going to be having your products in them. that it may be some other inverter, some other battery even, hopefully not, but who knows?
Well, I mean, yes, we have had occasions where people have used our enclosures for other people's batteries, but predominantly by offering a range of enclosures, it gives the installer the flexibility to choose the right enclosure to suit the application. So rather than just having one or two products that they have to then try and make fit the job, whether it's a small cabinet or a large cabinet or a big installation, we have maybe 15 different enclosures.
Wow.
That gives the installer to design the solution to make it easy for them to install to suit what the customer needs.
So just give me a range from how many batteries to how many batteries?
The smallest enclosure we build takes 3 batteries. The largest we do takes 20, but then you can parallel those.
Right, so infinite.
Yes.
Until your DC bus runs out of copper.
Yes. Yep. Exactly.
Wow. Well, let's go and check out the rest of the manufacturing. This is the warehouse where you've got a lot of stuff stored, but I know you actually make the batteries, so let's find out about that.
All right, let's go this way.
Yeah, cool. So, Bradley, pile of cardboard, what's this all about?
We just felt that when our product went out, it needed to be well protected, but it also needed to carry our identity. So rather than the basic packaging that quite often the metalwork comes in, we've done our own sort of double core flute packaging with our branding on it.
You know what I like best about this?
Recyclable.
It's recyclable. I love it.
So everything that we're doing, the focus has been on recycling. However, the final frontier is we have a 3mm piece of foam to protect the battery. We're investigating different starch-based replacement foams. Not easy to get in Australia at the moment. There are companies that do it in smaller sizes, but that's our current project, is so that when our batteries arrive, everything that they come in will be fully recyclable.
You know, I've installed a competing manufacturer's battery, and it was 3 10 kilowatt hour units.
All right, yes.
The packaging filled up 9 silo bins of unrecyclable polystyrene.
Yes.
It was the nightmare of polystyrene.
And it's important to protect the product. But we're sort of like even the plastic shrink wrap. We're experimenting with fully recyclable versions of that as well.
You can get edible shrink wrap too.
Oh, right.
Yeah,
What
if you're
flavour?
really hungry, you can just chew on these.
Like if it's black, is it licorice? Sorry, I like aniseed.
Me too.
Yeah. One of my philosophies as a manufacturer is to try and support other Australian manufacturing businesses. So, for example, to comply with the requirements of AS 5139, we're adding more and more touch-safe or insulation between live parts so that it can't be accessed externally. So the polycarbonate is all formed for us here in Victoria. So in some instances it's just routing out flat panels, but we also do a lot of folded panels so that people can't get their fingers around to touch live parts.
Right. Okay.
And
what's this over here?
another example is with the copper bus bars. All of them are, all the machining and cutting is all done here in Victoria.
These look like gold bars, not coffee bits, but it's pretty impressive. So,
Well, the price of copper is getting close to that of gold, so
what sort of current rating will a bar like this have?
that's rated for 1,000 amps.
1,000 amps. Wow.
So typically with 48 volt DC systems, that will allow you to do the equivalent of we'd run maybe up to about 1,200 amp hour of lithium, which in lead acid terms is about 2,500 amp hour of lead acid as a lead acid replacement.
Wow. Yeah, that's a lot of battery.
Yeah.
Wow.
So by providing the cabinets pre-wired, what would have taken 2 days of heavy lifting, of multiple cables, torquing up bolts, typically 2 people could do in half an hour.
So when you buy a pre-configured cabinet, it's already got the bus bars in there. It's got
all the cables,
the NOAC DC isolator, all of the cables with the Amphenol connectors on it.
Yes.
So there's a day's work
Yes.
saved.
Yes.
Right.
And We sort of can then control the installation. So we choose the cable. We have our quality control systems when we're terminating the cables. So we make sure that they're terminated properly. Because as you can imagine, if you're doing the same process over and over and over again, there's always the chance that you'll miss a crimp.
Yeah.
And so by taking that element of risk out of the installation for the installers, we find that they generally will have a better experience. With our quality control in assembling the cabinets, we have one employee who will then torque up each of the bolts on the bus bar. Then the second employee will come along after the job's finished and recheck.
Right. Two sets of eyes.
Yes.
Yeah.
On everything we do.
Okay.
Pretty much everything we do in the manufacturing process is checked off by a second person.
So these are all the raw components. Shall we look at the assemblage?
Most definitely.
Cool.
This area here is where we do cabinet assembly, and so this end here is where we fit out cabinets to customers' requirements, and over here is where we have our standard cabinet assembly area.
Wow. Check out all the connectors.
Well, because we try and meet customers' demands, we do a lot of pre-build. So that way, when we come to build the cabinets, they're on their lunch break at the moment, but as we're building cabinets, if we have the sub-assemblies all pre-made, then it doesn't hold up. And we've tried to standardise as much as we can so that we use the same materials on as many products to simplify the stock
I
holding.
think the automakers taught you that one. Yeah, just use one size nut everywhere. Don't
Yes.
have 10 different nuts.
Yes.
Yeah, if possible.
And so over time, we've sort of been able to simplify how we do things. In the early days, everything we did was using hand tools, and then we've gone to sort of different battery tools, and now we're working with different hydraulic and air tools.
Oh, nice.
So we're just gradually, as volume goes up, part of it is being able to have repetition. Part of it is preventing staff from having sort of repetitive strain injuries, and it also allows, so that we don't have one staff member doing the same thing all day, every day for months. We cross-train our staff so that they can have a bit of variety in the work that they do.
I think Volvo pioneered that in the auto industry where one team did the whole job. So they all knew everything within
Yes.
their expertise level, but it wasn't boring. That was kind of the key thing.
And we also find that it gives staff the opportunity, if they're coming in fresh to a different area, then they say, oh, why are you doing it this way? And so they'll then provide ideas or feedback on different things we'll try, and sometimes that helps to improve the whole process.
Cool. Well, this is the assembly area for the cables, the manufacturing of the cables.
There's only the cables for the cabinets.
Yeah.
So in the next room that we'll go into is where we do all of the smaller cable assemblies to suit the inside of the battery.
Well, let's go and check that out.
All right.
Cool. Wow, check this room out.
Well, this is our main battery manufacturing area. So on the right-hand side is where we do all of the sub-assemblies for all the components that go inside the battery. Down the back corner is where we do the actual battery assembly. The batteries then move across to the other side where each individual battery is tested. So we do a charge and a discharge. We have a thermal camera so that we can check for hotspots or any sort of connections that aren't made correctly. Once that's completed, the batteries come down to this side here.
Yeah, so this is assembly of the cells into the cases here.
So that happens down in the far end.
Oh, right down the end there. Yep.
So in this section here is where we do all of the sub-assemblies.
Yep.
We're implementing a QC process, which we're working towards ISO 9001.
Right.
So every step of the process, there is a job control sheet where the job's assigned. There's any notes or if there's any wastage or variations. And then before it goes on to the next process, we have a supervisor that will do a quality control check, and they will check every individual component.
Right, so these are all the circuit breakers.
Yes, they're the circuit breaker assemblies.
And this is before they go into the circuit breakers.
Yes.
Right.
So again, they have a separate job sheet.
Yep.
And you can see with these that we haven't heat shrunk them yet. So we actually do a mechanical and a physical, a visual inspection prior to the heat shrink going on.
Oh.
So that way, if it hasn't been crimped properly, you're not hiding it underneath the heat shrink.
Yeah.
So again, every step of the way, we do a double check. And the beauty of that is we have a very low, almost negligible failure rate in the field because we do these little minor checks during the manufacturing process.
And they're duplicated in some form, like you said, with tightening of bolts. There's two people involved.
Yes.
So there's documentation process. There's double checking. There's not hiding any potential faults before you've done the check. Right.
So part of the quality control process we're implementing is that every single process that we do in building a battery, we have a sheet that documents. So there's the finished product, the steps to achieve the finished product, and if you flip the sheet, then
the tools required.
The tools required and the components required to build it. So that way, because I mentioned before how our staff get moved around to different processes, if they haven't performed this process for a while and they need a reminder, then the supervisor will issue them the job sheet, gets stuck to the workstation, and they've got a quick reminder of how to build that particular component.
So is there an induction process for new staff?
Most definitely. Every staff member goes through an overall induction for the business, but then we provide a training regime and a refresher so that they're trained individually on each of the processes.
Right. This is a great aid memoir. You know, gee, I forgot step number, get it around the right way, 5.
Yes.
Fail.
And so any one of our staff can come back, and if they're assigned to build this sub-assembly, there's all the information there for them to do it.
So you've listed the author and you've got the date that's created, so it's all traceable, and if something changes, you know.
It's all part of our preparation for ISO 9001.
Right, fantastic. So where we're headed now?
This is our battery testing area. So every battery that we build, we will put through here to do a charge and discharge cycle, and we test with a thermal camera.
Ah, so every battery gets tested?
Every single one.
Wow, that's impressive.
So
it's very time consuming.
Oh, look, the cycle takes about 20 to 30 minutes. However, we just feel that this provides the customer with a better experience. We have very few, if any, DOAs.
So these are actually charging these batteries and discharging them?
Yes. So to be compliant with UN 38.3, we have to ship the batteries in a discharge state. So we will do a charge and a discharge. We'll check the batteries with a thermal camera. That way there's no hot cells or loose connections, and that way they're ready to ship out the door.
All right, so every battery's proven before it leaves here.
Yes.
And with the covers off, you can do the thermal imaging.
That's correct. We have a FLIR thermal camera, and while we've not really picked up any problems with the cell packs because they're well matched and balanced before they're assembled, we do look for hot joints. So that way, if a screw's been over tightened, that actually, when it stretches the metal, it'll actually create a hot joint.
Oh, really?
So, if a staff member's been too enthusiastic, we can pick it up. If the circuit breaker hasn't been tightened properly, we can pick that up, just all by the use of the thermal image.
So we've got about a dozen of these beautiful multi-pluses here.
Yes.
Testing. But you've got a newer system, I believe, for testing your latest generation. Because we're looking at adding more automation to our business, rather than moving one battery around at a time from assembly to testing to lidding, we're developing a system using a caddy. Initially it'll be manual, but then we're working towards having robotic caddies. That way we'll move the batteries into a testing station. We'll be able to test 5 or 6 batteries at once, and we'll just remove some of the manual handling elements. We've got sort of a precursor to the design in our 120 volt testing over here. Let's go and check it out. So, robotic caddies, that little things that run around all by themselves?
Yes. So that's sort of one of the things we're working towards.
Wow.
In this section here, this is sort of the precursor to what we're looking to doing. We're testing, these are the 120 volt batteries. So we test 6 or 7 at a time, and this is an early precursor where we've got the 120 volt inverter, but then we've got smaller 24 volt power supplies so that we can address the amount of power going to each individual battery. That way, if there are any anomalies in the cell packs coming out of manufacturing, we can correct it here. So when the batteries get to site, they're all in the same condition.
Oh, right. So you're pre-balancing them here.
Yes.
But you're also testing them as a block unit.
Yes.
Because you've got a communication system that allows you to talk to each of the batteries, or is that the system for monitoring each battery?
Some of our product has a BMS that comes from an overseas factory. However, we have developed our own range of BMS boards that we use in some of our products, which allow us to monitor individual characteristics inside the battery, such as temperature, cell voltage, and whether the strings are balancing, if there's any problems. So yes, we've got this connected up to our PowerLink module, which then talks to a cloud server, and so we can remotely monitor the conditions of the batteries as well.
Right. So you've built some monitoring into the batteries for the production process. It's not used in the for customer end, is it?
We have limited release for customer applications.
You do? Right.
So for special projects, etc., requiring monitoring,
Yep.
we will include the Australian-made BMS board. The part of our philosophy was in providing a lead-acid replacement battery solution, energy storage solution. We wanted to keep it simple for installers in the field, and because a lot of manufacturers are focusing on energy density and some of the features that their solution will provide, it includes typically a CAN bus communication so that the inverter and the battery can communicate with each other to get the optimum outcome for the battery. By doing what we call a self-managed battery, we put a lot of effort into the processes before the cell pack's made. So our requirements are a little bit tighter for cell matching. Our requirements are a little bit tighter on the way that the pack's assembled. And so by using a fairly basic BMS, we're able to achieve that 10 years warranty, the reliability over 10 years, without introducing the complications of having to maintain the CAN bus communication relationship between the inverter and the battery.
Yeah.
Now, there are some applications where having that is beneficial, but in a lot of applications, as long as the battery is reliable and you have a quality product like Selectronic or Victron or SMA, which can manage the constant current, constant voltage charge regime of the battery, just as they've done for the last 20 years with the lead acid,
Yeah.
we can achieve the same sort of reliable outcome using lithium that people have experienced on the whole with lead acid in the past.
So, white batteries.
Well, these are our Eco PS model. So the PS means that it has the Australian-made BMS in it, and that's what allows us to monitor, like there's 4 temperature probes inside, so 2 in the cell pack, 1 on the BMS board and 1 on the heatsink. That way, again, a little bit like going to the doctor's. Doctor takes your temperature. If the temperature's a bit high, then you know that something's not working quite right. So rather than waiting 18 months for the battery to fail, by looking at it early on, we can get a bit of a feel for whether some settings need to be changed or whether it's an early indication that we need to do a warranty swap out.
So you're monitoring voltage, current, and temperature.
Yes.
Yeah. And those 3 things can be called state of health.
Yes.
Yep.
It sort of allows us to get a feeling for how the battery's working. So if the cells are balancing at the top of the cycle, if the cells are all working together in harmony, and it just gives us a bit more of an understanding, especially in applications that are more critical, where a self-managed battery might not give the customer the confidence that they need for their project. Then we can use the Australian-made BMS and monitor it remotely.
Right. So what are these little mythical creatures up here?
One of the challenges when you go to larger inverter requirements, typically the industry will move to higher voltage batteries. So especially once you get above 10 or 20, 30 kilowatts, then the natural solution at the moment, because lower currents, higher voltage is lower currents, means that your bus bars, your cables, etc., can be smaller. However, part of the challenge with that then is you lose some of the granularity of the system. So by staying with 48 volts, it allows systems to be more granular. It also means that you don't have a single point of failure. If you have a 400 volt or 800 volt battery, if there's a problem that BMS picks up, it shuts down.
Right. It's one string. Yeah.
Yes, it shuts down the whole system. Whereas working with 48 volts, every battery is an independent unit. Every battery has its own master BMS. And so it provides you the granularity when you're designing. It also means that if you have a faulty battery, it isolates itself. The rest of the system keeps working. You can hot swap the battery out if you need to. You can also add more batteries without having to shut down the whole system. And so to achieve, while we use our installers, our customers use Victron, SMA and Selectronic typically, and they have the ability to scale up. At a certain point, it becomes a bit cumbersome and takes up a lot of space.
So you're talking about modularity of batteries, but these look like little something or others.
We have found a couple of manufacturers out of Europe that build modular inverters that can scale up to 1 megawatt or more using a 48 volt DC bus. And so Pixie is one brand which build a very sophisticated on-grid or grid following inverter. And we also use C+T, which has two inverters in one, so they do grid following, but also grid forming. So they can be used more easily for off-grid and for grid forming for the likes of Fronius and SMA, and Enphase for sort of off-grid AC coupled systems as well as being DC coupled.
So each of these is an inverter?
Yes.
And what sort of rating are these?
These modules are 3.3 kilowatts.
That's 3.3 kilowatts?
Yes. So that whole frame is 30 kilowatts, three-phase.
Wow, that's amazing.
Yes.
And I believe they're hot swappable too.
Yes. You can just grab a module and pull it out.
Can I take it out?
Yes.
Look at that. That is the cutest looking 3.3 kilowatt inverter I've ever seen. It must be like 2 kilos.
Yes. So the engineers out of Norway had a lot of experience with 48 volt DC, and so they developed this range of bidirectional inverters.
I remember back to the days when I did install stuff. A 3 kilowatt inverter weighed something like 40 kilos.
Yes.
And now we're down to like 2 kilos.
It's a big difference.
Hot swappable, modular, scalable, grid connected.
Yep. This particular product is AS4777 approved, and so other than the normal regulatory requirements and approvals that you'd need to build bigger systems, using their gateways in the master-slave arrangement, you can build up to 1 megawatt.
Right. Wow. So you were talking before about one of the advantages of having a 48 volt DC bus was the modularity, the redundancy that you have, that any one battery would shut down, but you'd still have a working system. So you've now got this capability at an inverter level.
Yes.
So if one of these fails, it still works.
Yes. So it will isolate itself. You'll get a red light. You'll pull the module out, plug another one in. The system will program it and it will start running straight away.
Just to reiterate, that was actually operating when you unplugged it?
Yes.
And there was no sparks or...
No.
No?
Yes.
Wow.
And so as I said, we've got the advantage of this on-grid product. It does have some limited EPS mode. However, we've also got the C+T product, which has full off-grid capability.
Wow, fantastic. Hey, what's this piece of kit?
It's a recent acquisition last year. It's an Arbon cell tester. So this device is from the US. It's an 8-channel model. So we can test up to 8 individual cells or 8 strings in a battery at a time. And so it allows us to understand the characteristics of the cell during charging, discharging and balancing.
What sort of characteristics?
Charging.
So current,
Yeah, sorry.
voltage, temperature, impedance,
yes,
all those things?
Yes, so we can verify what the manufacturer's specifications state.
Yeah. And power capacity?
Yes.
So you're kind of proving that what you bought is actually real.
Yes.
And it's living up to your expectation. Is this the actual cell holding thing?
So yes, because it's an 8-channel device,
Yep.
we can either do one cell at a time.
Wow.
And so at the moment, we predominantly use cylindrical cells because of mechanical stability, because their ability to handle different temperature environments without sort of a highly sophisticated BMS. But we can also change from this to some clamps, and that way we can measure strings within the battery.
And I see there's a battery under test in here.
Yes.
Let's just move over and have a look at it.
So different lithium cells have different characteristics. And so on a very basic level, some cells are designed for energy storage, and so the manufacturer will design it for a 3C discharge. Other cells are designed for high discharge, and so they might have a 10C discharge. So if you use the cells in the same application, they will behave differently. So in the short term, you can grab a little AGM battery and it can be solar, but it'll only last 100 cycles. So by understanding the characteristics of the cell, we can make sure that we're using the right cell for the right application, but also it allows us to do batch testing when cells come in from overseas
Yes.
to make sure that the supplier hasn't accidentally put the wrong cell in that production run.
Yeah.
But it also allows us to evaluate new suppliers. So traditionally, even with accelerated testing, it might take you 3 years to test whether the cell has the capacity to get you your 4,000 cycles or your 10,000 cycles. Whereas with the Arbon cell tester, we're able to actually ascertain the expected life cycle characteristics of a cell via computer.
So sort of accelerated testing using some software,
Yes.
understanding the characteristic of the cell and seeing
Yes.
how those changes occur. Can you also do a lot sort of like cell fingerprinting? Like you said, you get different manufacturers supplying cells to you, and is there a way of identifying that they're actually the same type of cell, like in terms of capacity, impedance, all of that?
It's very new days for us with the machine.
Yep.
We have a full-time test engineer, and so he at the moment is bringing himself up to speed on how the machine works and what we can get from it.
That'll be the illustrious Sean.
Well, Sean's his manager.
Oh, okay.
And Sean's the one that convinced me to spend the money on the machine.
Right.
However, we do actually have a full-time test engineer as well.
Oh, okay. Right.
And he's the one that is designing the tests that we want to perform.
Yes.
He's sort of, it's like anything, understanding the characteristics of the machine, but he's also doing some work on the side so that we can automate the transfer of the data into
Yes.
our own databases.
I guess what you're telling me is manufacturing a modern, highly reliable battery is not just get the components, put them in a box, ship them out. You're going through all that verification of the components before you put them in a box and ship them out.
One of the interesting things is because of the speed of the growth of the industry, there's a lot of copycats, and they will take what appear to be good quality components and put them into a product without really understanding how the relationship between those different components work. And so what we've got to be careful of, especially in Australia with Australian consumer law, is that if we promise someone a 10-year warranty or a certain experience, we have to be confident as an Australian manufacturer that we can deliver that. And just by grabbing some components off the shelf from potentially quality manufacturers doesn't necessarily guarantee that you're going to get the right outcome. So rather than just be a box mover or be someone that's assembling third-party products, components into a product, we're sort of taking the approach of fully understanding the components and making sure that when we build the product, it's actually going to do what the documentation, the supplier specification says. And it's been quite interesting, like in our evaluation of third-party BMS products. They appear to work well. However, when you actually test them, and we'll show you some of the other test equipment we have, when you actually test them, there are anomalies that, because for a variety of reasons, they won't actually do in the long term what the specification says they'll do.
Right.
And it's just design improvement, etc. So rather than relying on third parties to be the ones to decide whether the product needs improvement, our engineering team here is recommending or designing those improvements ourselves. So we have some control over the outcome. The next piece of equipment we have here is a computerized bidirectional DC power supply. So it's rated at 0 to 300 volts and 0 to 450 plus or minus 450 amps. So we can put complete battery systems under load, we can monitor them, and we can see how they perform both in charge and discharge. We can test for capacity. So while the cell may have a certain capacity, when you join them together in parallel, does that performance change? You know, what impact is there? Algorithmic relationship between the number of cells, or is it linear? Just so that we again can be confident that the whole battery pack is going to perform as well as the sum of the parts.
Right. So these are some of the test packs here that you're working with.
So, not that he's done a very good job at it, but our test engineer, one of his mantras is to try and destroy things. And so whether it's a testament to the components that we're using, or his testing has been more positive than destructive.
Where's your bucket of sand then?
Well, yes, I don't know whether that's come with us from the last factory. So we also have a smaller computerized power supply.
So this one's called a battery simulator?
Okay, so that's the power supply.
Yep.
This fella here is a battery simulator.
What a cool name, Bloomy.
Again, it's a product out of the US.
Yeah.
These are 12-channel battery simulators. And so because our 48-volt battery is 16-channel,
yep.
The lithium,
Two of them. Yeah.
the lithium cells are 3.2 volts nominal, so 16 cells gives you your 51.2 volts. So we have two of these. The beauty of this is it allows via computer for our engineers to configure any known possible fault scenario within the battery and see how the BMS responds.
Without destroying a battery.
Without destroying a battery, because it might take you a day or two to get a cell pack out of balance, or to create a deep discharge. So via computer, they can create all sorts of scenarios. They can have, one dud string, or they can have, 3 strings that are overcharged and 12 that are undercharged.
So we're going from cell testing over here to BMS testing over here.
Yes.
Right, gotcha.
And then that way, again, it allows us to, rather than just build a battery and put it out in the field to do some beta testing, we can do a lot of work here in the engineering department first, before we put product in the field.
Something I've learned about BMS is they sound like fairy dust sometimes. They're all the same. You just sprinkle them on a battery pack and it's all good. But actually, there's a whole range of features they can or can't
very,
have,
very
can
different.
or do or don't have.
Yep.
And this is going to be able to test that it can cope with all that irregularity at the cell, the battery pack level.
Lithium ferrophosphate cells in themselves are actually quite stable.
Yeah.
I refer to it as lead acid on steroids. There's lots of characteristics about LFP that are very similar to lead acid. It does it many, many times better. But the one adage that is true is with lead acid batteries, you wouldn't parallel more than 1 or 2 or 3 strings because you get different internal resistances. Now, because the internal resistance of lithium ferrophosphate is a lot lower, those problems are far smaller, and you could operate LFP without a BMS. However, because of the cost of the investment, you want to protect that asset. But and if something does go wrong, it can go wrong big. Because you've got to put 16 strings in parallel to achieve your 48 volts, you actually do have 16 parallel strings, and so by
16 strings in series.
Thank you. I'm getting a bit carried away there. Because you have 16
cells or strings in series, you have minute differences in the internal resistance of each string.
Yeah.
So the BMS board is just sitting there happily, putting a few milliamps, keeping all the strings. So every time you do a charge, you're just doing this little micro balance.
Yeah.
And so that's where the BMS becomes critical, is you get a longer service life out of your battery by doing that little micro balancing every time it charges, and it keeps all the cells up in capacity. Otherwise your capacity would reduce to the lowest common denominator. And by doing this, we have a better understanding of how the BMS board is going to look after the cells.
Can we stand up because my legs are burning? Yeah.
All right. Now,
come over here.
Look,
I just had a fun analogy.
Yes.
Rowing, like when you have a whole bunch of people all rowing together, like a rowing eight. An analogy of a BMS is if one of those rowing eights is doing a bit of a layback, whatever her name was,
Yes.
and not pulling their weight, the BMS comes in and sort of helps top up the zest of that rower, so they continue to all work together.
A little poke.
A little poke.
Yes.
Yeah.
Now,
this is your pie warmer. Wow.
this is our pizza oven.
Oh, pizza oven.
This is our pizza oven. When our engineering manager came to me and said he needed a heat chamber to test the BMS boards and batteries, and I suggested he buy a $400 oven from IKEA, or he sort of hung his head, and you could see him saying, do I resign now or do I resign later? But eventually he got the right equipment to do the job. So this allows us to test in a range of temperatures and a range of humidity, both our BMS boards.
It's humidity as well as temperature.
Yes, it's a full environmental chamber.
Right, wow.
So even our visitors from China, when they come to sit, they say, oh, very nice.
Yeah.
So, we can connect BMS boards in off the Bloomy, and
All right, so you're doing environmental testing on your BMS boards. What about the cells? Do you test those in here as well?
we can test the complete battery pack in there
the
as
whole
well.
battery pack can go in there.
Yes.
All right, it's just, I can see it's just a BMS in it at the moment.
Yes.
Yeah, cool.
So just that way, like with some electronics, we've had intermittent, like with some communications equipment, we had some intermittent problems in the field, and it seemed strange, but our engineering team were able to evaluate that with high temperatures, like someone had put this piece of comms gear inside of a sealed metal box out in the middle of the desert, with the high ambient temperatures that were inside this box, there was just that slight movement in the board, and it caused a solder joint to...
yeah, right.
So it was able to be duplicated
So
here.
it's not just the silicon doesn't like getting hot, it's the mechanical as well.
And so they were able to evaluate the problem in the field that it appeared in the field here in the laboratory.
Well, let's look at the... Gee, you've got a lot of stuff here. What's this one? I love the SP Pro.
Especially in our early days, for a lot of our testing, we've set up a series of racks for the SP Pros and the Victrons to use to do cyclic testing and just look for patterns or changes in cell performance. So before we bought some of the fancier toys, we were setting up these cabinets. They still have some use in accelerated cyclic testing, etc., but most of the detailed testing is done on the new equipment.
Right, so it's kind of like legacy testing.
Yep. And sort of controllable power packs, load packs. Behind you is our old. We used to use the 500 watt halogen lamps outside the front of the building.
Oh, here.
Yes.
Oh, right.
So
yes.
that was our original load
No,
banks.
this is the winter room warmer. Yeah, right.
Some staff would stand outside alongside them in the winter, while they're having their coffee breaks.
Now, is this a pizza oven as well?
No. This is. We have a couple of our staff are really into 3D printing. So when we are creating a test jig, or we need a box for interfacing and something to hold connectors, a couple of the chaps will create 3D models to make it easier for them to hold their jigs or to perform the tests.
Oh, cool.
They convinced me it was important to have one. So
Yeah. Every home should have one. You never know when you might need something 3D printed.
Yeah. And so again here, these are some PLC controlled and web monitored boxes that we use for cyclic testing.
Right.
So it was just at the time when we were first starting out, the Victrons were a fairly inexpensive inverter, inverter charger, and so that's what we used. It gave us the benefit of the shunt. We had the web and Modbus interface, and again, similar to using this electronic. They don't give us the fine control that the computerized power supplies do. But again, in our first couple of years, these were perfect for doing the type of testing that we were doing at the time. And we still use them occasion for, again, mainly cyclic performance testing.
Great. Hey, Bradley, thanks for showing me around your awesome factory.
You're welcome, sir.
It's amazing, from that little 1.5 square metre Canards storage unit to what have you got here?
8,000 square metres.
8,000 square metres. Wow.
If it wasn't for my wife, I'd still be there. I would have taken over half the Kennard storage site, but I'd still be there.
She got sick of walking between the two storage units.
Yes. Yeah. Well, at that stage we had 5, and she'd walk 50 metres that way to get the tape gun, and 20 metres that way to get the packing slip off the printer.
I mean, everyone starts somewhere. You've got to think of Steve Jobs and Wozniak in the garage.
His father's place. Yes.
That's right.
So, look, it's part of our journey and some good memories and experiences, but it's also exciting to be here and having the resources and the tools for our staff to do their job properly, having the space to be able to manufacture, and having the space to be able to store components so that we can improve delivery times.
Fantastic.
It's all fun.
Thanks.
You're welcome.